What is the kinetic energy and power per square meter of sunlight exposure? Those of you working with photovoltaic or solar electric systems may ask this question. So the answer is first finding the relationship between matter and energy, so E is equal to mc squared, where c is the speed of light as a constant. And then kinetic energy is 1/2 mass times velocity squared. So before we can work with kinetic energy or particles moving slower than the speed of light, we have to first solve for the equivalent mass or plasma found in the sunlight. So we can just algebraically rearrange the mass value irrespective to the Lorentz factor as simply just energy divided into the speed of light squared is the equivalent mass of the energy or light if it wasn't at the speed of light. So that would be a simplified explanation. So energy and mass are one and the same in the appropriate environment. Light passing through or upon matter is the sequence of photothermal energy. Then it may convert into photoelectric, and then photochemical, and then electromechanical, depending on the material. As in inorganic or biological materials. So we are gaining and or losing electrons or ionization. So that is the electrons in the light, as in the light waves. The electrons in the matter of whatever is being exposed to the sunlight. And then, of course, the totality of the electrons as both light plasma particles and light waves together. So wave particle or wave particle duality of light, and that is just the photon concept, which is realized through light in the atmosphere. So we would just call photons as light in a simplified definition. So wave particle or wave particles So let's move on to the sun now. We have the sun, and then we have the propagation of sunlight in the form of wave particles or photons, i.e. sunlight, which then reach an exposure area of 1 square meter as a test. So it is understood that 1 square meter of sunlight is going to receive 1,000 watts per square meter of sunlight photothermal power. So it's over the function of time, so 1,000 joules per second or 1,000 watts, where 1 joule per second is equal to 1 watt. So we have to carefully extract the mass from the light by rearranging the E is equal to mc squared equation into m is equal to E over c squared. We need to do that first before we work with the kinetic energy equation. So if we substitute the mass component of the kinetic energy equation with the equivalent mass transfer in the light in the form of particles moving at the speed of light or plasma, the fourth state of matter, we then now have a legal and valid transfer into kinetic energy. So in this case, we're going to work with 1,000 joules of energy, not over the function of time, so just the energy. If we were to divide the 1,000 joules per 1 second, then we would get the watts. but that would be only in photothermal power. So we just take 1,000 joules, divide it into the speed of light squared, so 3 times 10 to the 8th power meters per second is the speed of light, its value squared, then times the speed of light as a constant. So in this case, v squared is equal to c squared. So if we make this calculation, it's always 1/2 the equivalent energy from the source photothermal energy of 1,000 joules per square meter. So we get 500 joules kinetic energy per square meter of sunlight exposure. So if we divide this into 1.36 joules per foot-pound, we then get 367.6 foot-pounds of kinetic energy, or 500 joules kinetic energy per square meter of sunlight exposure. So each second, 500 joules of energy are transferred, so that's 500 joules per second, or 500 watts of power, or 367.6 foot-pounds per second. So this then calculates the power per square meter of sunlight exposure. So then we solve for the equivalent horsepower. And this is 500 watts divided into 746 watts per horsepower, which is equal to 0.67 horsepower. So to answer the question, for quick reference, what is the kinetic energy and power per square meter of sunlight exposure? The answer is 500 joules, or 367.6 foot-pounds of kinetic energy per square meter. And for power, 500 watts, or 0.67 horsepower equivalent per square meter of sunlight exposure. So these are the maximum kinetic energy and power values per square meter of sunlight exposure. And that proves that the photothermal transfer efficiency is approximately 50%. Thank you for watching this presentation, and have a great day.